Okay, now in the last session we were talking about application of free body diagram method, and towards the end we also discussed about the type of force that acts in stretched strings or threads, etc., called tension, and how to incorporate that into free body diagrams while solving. So we'll continue with that, and we will look into systems with pulleys today. So let's begin. Okay, so let's start by looking at an example with the application of the concept of tension again. So let's say we have a system like this consisting of 3 blocks, which are connected together by light threads like this. And this is a smooth frictionless surface. And we are pulling this with an external force acting horizontally equal to F. So let's say given situation is the mass of the block A is equal to 2 kilograms. The mass of the block B is 1 kilogram, and the mass of the block C is again 2 kilograms. Okay, and the force applied is equal to 10 newtons. And as I said that these are light threads. So if this thread develops a tension T1 and this thread develops a tension T2, and the blocks start accelerating at the rate of A. So what we have to do here is make free body diagrams for the individual blocks A, B, and C, and find out the values of the acceleration and tensions T1 and T2. Yeah, I will be discussing the doubts for the assignment paragraph towards the end of the lecture. Yeah. We will be discussing them today itself. Don't worry. Okay, so let's begin with this question. So let's start by making the free body diagrams of the individual blocks. So if we look at these blocks on A, there is one horizontal force tension T1, weight, normal reaction, and will have an acceleration E. On the block B, however, there are two tension forces, T2 towards the left and T1 towards the right. Normal reaction and weight, and acceleration E. And this one, there is the horizontal external force, which is acting towards the right, and there is tension T2 acting towards the left. And this will also have the common acceleration E. So all 3 blocks will have the same magnitude of acceleration because they are connected by threads, okay, like this. So now we can write the equations for the individual blocks. So for example, for the block E, we have the equation T1 is equal to mass into acceleration. Okay. And the vertical equation, normal reaction, is balancing the weight. For the block B, we have the net horizontal force T2 minus T1 is mass into acceleration. So let's say this is our equation 2, and normal reaction is balancing weight. And for the third block C, we have the net horizontal force F minus T2, and that is equal to mass into acceleration. That's equation 3, and as usual, normal reaction is balancing the weight. So we have this. So now let us simply add the three equations. So we'll get rid of T1 and T2, and we'll get F is equal to sum of mass into acceleration. So we'll get 10 newtons is equal to 5a. So the acceleration, the common magnitude of acceleration will come out to be 2 meters per second square. Yeah, because they are connected by the thread, Harsh. The acceleration of the three blocks will be the same in magnitude because they are joined by threads. No? So when you pull the block C, C will pull B along with it because it's joined by a thread. Unless the thread breaks or the string, Similarly, B is attached to A with another thread. So if B starts sliding with acceleration A, it will pull A along with it with the same acceleration. You understood now? They are connected by threads, no? So they'll have to move together. No? That's why. Okay. Now, once you got the magnitude of the acceleration, you can substitute that in the equation. So now substitute A equal to 2 meters per second square in equation 1. So you'll get T1 is equal to 2 into 2, or T1 is equal to 4 newtons. And then substitute in equation 2. So you have T2 minus T1 is equal to this. So you'll have here T2 minus T1, which we just saw is 4 newtons, is equal to mass of B, which is 1 kg multiplied by the acceleration. So finally, you can see that T2's magnitude comes out to be 5 newtons. So you got the three unknown quantities, T1, T2 tensions and acceleration A. And of course, the normal reactions are balancing the weights. So that is not something which has been asked in the question, but they are also there within the system. Okay, so hope this question is clear. Note this down quickly. We'll be discussing more questions like this soon. So in a sense, this question is like a quick recap of everything we've learned in Newton's laws of motion, including the concept of free body diagram, the normal contact force concept, the application of F is equal to ma, the concept of tension or tensile force, etc.
I am Poison Ivy from Batman.
Yes, the vertical net force will be 0 because you can see the blocks are accelerating only horizontally. So this will show you that, if required, you can always calculate. If you take G as 10 meters per second square, for example, then this is showing you the normal reaction is 20 for this. The normal reaction is 10 newtons for this. The normal reaction is again 20 newtons for this. Okay, but yes, that's why weight minus normal reaction or normal reaction minus weight would be 0. That's correct, Harsh. Okay, so hope this is clear. So let's look at another problem next. Now, next example, we have the situation of an inclined plane. Smooth inclined plane which is at an angle of 30 degrees with respect to the horizontal. Okay. Now there's a combination of two blocks which are again joined together by a light thread. Okay. Now what we want to do here is we want to apply a force. We want to pull the block B with a force parallel to the inclined plane such that the system should have an acceleration of E. Okay. So given that mass of A is equal to mass of B is equal to 2 kilograms. Okay. G is equal to 10 meters per second square. Okay. Find the magnitude of F, okay, acting parallel to the inclined plane as shown. Okay, so that the acceleration of the blocks is of magnitude 2 meters per second square. Okay, so how much force I should be applying so that this happens, and also find the tension in the thread. Okay, in the thread which is joining the blocks A and B. Okay. So again, same situation, make the free body diagrams of blocks A and B and work out this thing. Okay, so this time when we make the individual free body diagrams, you can see that for the block A, the forces will be the tension in the string acting up the inclined plane, components of weight mg sine 30 degrees, mg cos 30 degrees, okay, and the normal reaction acting like this, and it has the acceleration along the inclined plane, which is E. Whereas further up the inclined plane for the block B, you have tension acting downwards, okay, the external force acting in this way, again same mass, so components of weight mg sine 30, mg cos 30, so same normal reaction n. Okay, so we will take our x and y axis like this, and we've already resolved the forces. Okay. So for block A, we'll have the equation T minus mg sine 30 is equal to ma. Okay. Of course, normal reaction is mg cos 30. And for the block B, we have the equation F minus T minus mg sine 30 is again equal to ma. Okay. And normal reaction is again, of course, mg cos 30. So once again, we can just add the equations 1 and 2, and we'll get F minus 2 mg sine 30 is equal to ma. So F minus 2 mg into half is equal to ma. So 2 ma, my mistake. So you're adding the two equations. So 2 ma here. So F becomes mg plus 2 ma, or this much. So the magnitude of the force you have to apply will become 2 kilograms into 10 plus 2 into 2, 4. So 28 newtons. Okay, and then we can substitute that back in the FBD equation to find the tension in the string. Yeah, this is the very standard thing on the inclined plane, Harsh, that we have discussed, that on any inclined plane, how to take the components of the weight of an object. So if this angle is theta, then the mg vector which acts vertically downwards so this vector so we draw the axis like this along the inclined plane and parallel to the inclined plane. You can see that this is forming a right angle triangle. So this angle here is 90. So this angle here is 90 minus theta. So this angle is theta. Okay. Hence, when we take the components, this component becomes the cos component, and this component becomes the sine component. So always on an inclined plane, if the angle of the inclined plane with the horizontal is theta, then mg's component along the inclined plane or parallel to the inclined plane is the sine component, mg sine theta, and mg's component normal or perpendicular to the inclined plane is mg cos theta. But remember, theta is the angle of the inclined plane with respect to the horizontal. Is it clear, Harsh? So just keep in mind this geometry. If you draw the normal to the inclined plane, good. Then okay, and draw the horizontal and vertical. Then this angle here is equal to this angle here. Just keep this in mind. Right, now coming back to this, we have found out the force. Now the tension from equation 1, you can see tension will become mg sine 30 plus ma. It will exactly become half. Mg sine theta is acting down the inclined plane, beta. Bhargav, so what is happening? See, on block A, tension is in the positive direction because we are taking our x-axis along the positive direction, upwards, and mg sine 30 is along the negative direction. So net force is what? Plus T, because T is along the positive direction, minus mg sine 30. And that is mass into acceleration. Whereas for block B, what is happening? Tension is acting down the inclined plane. So it is minus T minus mg sine theta, which is the one which is acting along the positive x direction, is F. So F comes with the plus sign here. So F minus T minus mg sine 30, that is the net force along the x-axis for block B. ठीक है ना? So the sign convention is according to the direction of the axis. और axis मैंने ऊपर की तरफ क्यों लिया x axis? Because the acceleration is up the inclined plane. Because the block is moving up in the upward direction, so I've taken the upward axis as positive. Okay. Now, next up, we'll be discussing about systems with pulleys. Okay, so let us understand. Pulley-based systems. So let's look at some sort of standard examples. So we can, for example, suspend a pulley from the ceiling like that, or we can fix a pulley to the corner of a table like this. Okay. And then we can have a situation where we have a thread wound around the pulley. So that okay. And for example, we can have a situation where we have a block attached here and we are applying some force on the thread to pull the block up. Okay. Or we can have a situation where there are two different blocks of different masses, and suppose M2 is greater than M1, then this block will be sliding down. This will be going up like this because they are connected by a thread which is going around this kind of thing, which is a pulley. This is also an example of a pulley. Okay. And here, if we are applying sufficient amount of force, then we can use that to pull the block upwards like this. So these are examples of pulley-based systems. Okay. Now I'll explain the structure of the pulley in more detail. Okay, but just quickly go through this and make sure you understand this situation here. Okay, so the structure of the pulley here is going to be something like this. So in this chapter, when we discuss, a standard pulley, it will have these properties. It is with a smooth surface. Okay, so smooth again means frictionless surface. Okay, which means that the thread can slip on it. And secondly, it will have a fixed axle. So it is what we call a non-rotating type of pulley. It is a non-rotating type of pulley. Okay. And thirdly, it is going to be massless. That means it's very light in mass compared to the blocks in our system. Okay. So basically the structure of the pulley is going to be something like this. So three-dimensionally, it's some kind of structure like this with an axle. As we've seen, the axle can be fixed such that the pulley is suspended from the ceiling, or it can be fixed to the corner, etc. Whatever. Okay. Now, what we mean by saying that it's a smooth surface, that means that this surface is smooth. Okay. So any string which is wound around it, or any thread which is wound around it, it can slip freely. Okay. So if there's any thread like this, because the surface of the pulley is smooth, so the thread can slip freely on the surface of the pulley. And what we mean by the fact that it has a fixed axle is that this axle is fixed. So the pulley does not rotate. It's not the rotating type of pulley. We will come to rotating pulleys in a different chapter. Okay. And massless, of course, you understand what it means. This whole structure has a negligible mass. So when we make a two-dimensional diagram and show the pulley just like this with the axle, let's say attached to some surface like this, in 3D actually there's this whole structure like this. It's like a cylinder attached to two wheels like this, but the whole thing is fixed and it's attached to the corner of a table like this. Okay. This kind of structure. Yeah, so I will just scroll up so you can understand this whole thing once. So just take this down and then we'll understand how this is incorporated in systems. Okay, so let's look at an first example of application of this concept. So let's pick up this situation. Actually, you haven't finished? Okay, just. Okay, good. So let's look at this numerical example of this now. So here, let's say there's again a smooth surface. Oh, sorry, surface doesn't really matter here because you're applying a force. So the pulley that we are using is a smooth fixed pulley. Okay. Even when it's not mentioned by default, we should always take a pulley of this type, the one whose surface is smooth and one that doesn't rotate about the axle. Because the type of pulley which has friction on the surface and which rotates about its axle, we'll be dealing with in a later chapter called rotational mechanics. So in this chapter, Newton's laws of motion and friction, we'll only be dealing with smooth, fixed and massless pulleys. Okay. And the thread here is a standard massless or light thread. Okay. So what we're doing is that the mass of the block being 5 kilograms and acceleration due to gravity being this much, if the force we are applying from this side equals to 70 newtons in magnitude, okay, we have to find the block's acceleration. Okay, so immediately the thing we have to understand in the question is that, see, the end of the thread where we are applying the force, okay, it's a massless thread. Okay, so that is why if you make a free body diagram of that end point of the thread, okay, then the net force on it should be 0. So whatever tension acts on the thread, because it's a massless thread, so that means it will develop a uniform tension throughout its length, and that tension will become equal to the amount of external force we are applying, which is going to be 70 newtons. Once we know that, rest is easy. Now you just make the free body diagram of the block. Okay. So for the block, you can see there is tension T acting upwards, which is 75 newtons, and its own weight mg is 50 newtons. So it will have an upward acceleration Just a second, I'll share the file again. Yeah, so it will have an upward acceleration E such that T minus mg is equal to ma. So we have this as our first equation, and now we have this equation. So we substitute that here. So 70 minus 50 is 5a. So we'll get the acceleration as 4 meters per second. Yeah, so Harsh, see, this is what I've explained, that at the end of the thread, now, where we are applying this force, you just understand the action reaction principle. Now. You are applying a force, so the string will develop an equal and opposite reaction force, which is the tension. Now the rest is because it is a massless thread. Now we've discussed massless thread, always the tension becomes uniform at all points. So that's why this tension is going to be the same as the tension acting on the pulley here. It's going to be the same as this tension. Okay, it's going to be the same as, so it will develop a uniform magnitude of tension throughout, which is equal to the tension at the point P, which is nothing but 70 newtons. $75 nahi beta, 70 newtons. F is, oh that, achha, understood. Sorry, this is by mistake. Let's make a correction here. This should be 70 newtons. This is what we were pointing out, Harsh. Yeah, it should be 70 newtons. Thanks for pointing out. So people please make a correction in this. This is 70 newtons here. It's not 75 newtons. This one is 70 newtons, this value. Okay, so hope this question is clear. Now moving on to another very standard situation for pulley systems. In fact, this is the most standard type of example of pulley systems that you will see. But now we'll do it as a numerical example. In fact, this type of system, it is commonly called an Atwood system. Okay, a single pulley with two blocks like this, it is called an Atwood system, or sometimes even it is called an Atwood machine. It is to demonstrate the acceleration due to gravity or the principle of Newton's second law, etc. Okay. So Atwood machine consists of a single pulley, which is a smooth and fixed pulley, okay, and massless thread like this. Okay. So again, what we have to do is that, given this time, let's say the masses are let us say masses are 15 kg and M2 is, let us say, 35 kg. We have to find the acceleration and we have to find the tension in the thread. Okay. So because it's a massless thread, the tension will be uniform. Okay. To find this out. Okay. So to do this, we will make the free body diagrams. Okay. Separately for the block M1 and then for the block M2. So we'll see on each of them, there is tension acting vertically upwards. There is weight acting vertically downwards. Okay. But they have opposite accelerations. This one has acceleration A upwards. This one has acceleration A downwards. So for M1 block, the equation will become T minus M1G is equal to M1A, because the net force should be upwards because its acceleration is upwards. Whereas for the second block, the net force should be downwards because the acceleration is downwards. So M2G minus T is equal to M2A. Okay. Now just add equation 1 plus 2 and we get this. Which in this case works out to be this much. Okay. So please make sure you understand the sign convention. For the block M1, we are taking the upward direction as positive because the acceleration is upwards. Whereas for the block M2, we are taking the downward direction as positive because the acceleration is in the downward direction. Okay, next up, you can eliminate acceleration by substituting this in any of the equations. So you can substitute this value of acceleration in equation 1, for example. So T is equal to this, so that will become m1g into 1 plus m2 minus m1 upon m1 plus m2. So you can see that the tension becomes like this. Okay. In this particular example, the tension becomes this much. Okay, so these are the final answers that we are getting. Yeah, we'll be doing plenty of questions, Harsh, don't worry. All right, so let's look at the next example. So this time we have a block attached to the end of the thread here, and we have a block attached to the other end of the thread here. Meanwhile, the thread is going around a fixed smooth pulley like this, and this surface is also a smooth surface. So this is a massless thread. Okay. This is again a smooth fixed pulley, and this is again a smooth surface. Okay. So let's say given mass of the block A is 6 kilograms, mass of the block B is 4 kilograms, and G is equal to 10 meters per second square. So you want to find the acceleration of the blocks and the tension in the thread. Tension, the answer was 210 newtons, Bhargav. In the previous question, the answer was 210 newtons, which is coming by this substitution. Okay, so let's come to this question now. So you can see that the weight of this block, pulling it down, so that creates tension in this thread. Now, because the thread is massless, so there's going to be uniform tension throughout. Okay. So as a result of that, whatever is the magnitude of acceleration for this going down, same will be the magnitude of the horizontal acceleration of this. Okay, and of course on this block there is weight and normal reaction. So I made the FBDs directly in the question itself. So you can see now for the block A, we'll have the equation that horizontally tension is equal to mass into acceleration, and vertically normal reaction is balancing weight. Whereas for the block B, we'll have the equation weight minus tension is equal to mass into acceleration. Again, we are taking the downward direction as positive because the acceleration is downward. So again, add equation 1 and 2. So you can see that get this over here, or in this case 40 newtons is equal to 10a. So you're getting the acceleration as 4 meters per second square. Okay. And finally substitute that in equation 1, and you will get the tension as 24 newtons. Okay, so take down this question quickly, and with examples like this you will gradually understand very easily how to solve systems based on pulleys and blocks and strings. It is again just a matter of applying the free body diagram concept correctly. Okay, so hope this example was clear to all of you. Now let's try out another one. So now we have this inclined plane, and at the corner of the inclined plane we have a pulley attached like this with a thread going around it. So this angle is 37 degrees this time. And this is again a smooth surface. And this is a smooth fixed pulley. And G is equal to 10 meters per second square. Now given that the mass of block A is equal to the mass of block B, equal to 5 kg, you have to find the accelerations and tension in the thread. So just try this out. So uniform tension will be acting like this throughout the thread. Okay. And because B's weight is pulling it down and A's weight is divided into two components. So ultimately B's pulling force because of the weight will dominate and the system will have acceleration like this. So I've just simplified the problem for you by showing the tension forces and the direction of acceleration. Now all you have to do is show the other forces acting on blocks A and B, resolve any forces necessary, and write the free body diagram equations. Yes, very good, Harsh. That is correct. The acceleration will be g by 5 or 2 meters per second square, and therefore the tension will be 40 newtons. Anybody else who has worked this out, please send me the answers on the text message. Okay, so let us look at the individual free body diagrams. Okay, so for the block A, again you can see that you have to resolve the weight into the components. So mg cos 37 in this case, and mg sin 37. Normal reaction acting like this, and the acceleration of the block along the inclined plane. So for the block A, the equations will become, we'll have to take x and y axis like this. Okay. So we have t minus mg sin 37 is equal to ma, and we have normal reaction is equal to mg cos 37, and of course m is equal to 5 kg for both the blocks. Okay, so this one is the more significant equation, equation 1. Whereas for block B, we can directly look at the free body diagram here. So for this FBD, we can see that block B is giving us the equation mg minus t, because its acceleration is downwards, is equal to ma. So that becomes our second equation. So now it's the same standard method of solving the equations. First, try to find a combination such that tension gets eliminated. So here you can see the first equation has plus t, the second equation has minus t. If you just add them, you get rid of t. So we have mg into 1 minus sine 37 is equal to, now on the other side when you add, it's this much. So g into 1 minus 3 by 5 is equal to 2a. So you get the acceleration as g by 5, 2 meters per second square, and then substitute in the second equation or whatever. So t is equal to mg minus a. So 5 into 10 minus 2. So 40 newtons. That becomes the tension. Yeah, Bhargav, it's 2 meters per second square, right? Left hand side you have 1 minus 3 by 5, so 2 by 5. Right hand side you have 2, so g by 5. Okay, let's do one more question, then we'll move on to discussing some of the doubts that you have from the assignment I gave you last time. This time we have a system like this. Let's say this string joining A and B, this has a tension T1, and this string joining these two blocks, this has a tension T2. So given mass of A is equal to mass of B is equal to 3 kilograms, and mass of C is equal to 2 kilograms, and G is equal to 10 meters per second square. Find the accelerations and the tensions. Okay. Again, the pulley is supposed to be smooth and fixed. Yeah, you will need to predict it, Bhargav. That's correct. Okay. So in the previous question, it was easy to predict because both the masses were the same. But in certain cases, if the masses are different, then you will need to predict it. Okay. So I will tell you a trick of how to do that also. But first, try out this question. Okay, Bhargav, we'll discuss that if the masses had been different in the previous question, then how we would have predicted the direction of acceleration. But in the particular question, it was easy because both the blocks had same mass. So obviously the one which was vertically hanging will dominate. Okay, so this is comparatively easier because you don't really have to resolve any forces now. The blocks are on a horizontal surface. You just make the free body diagrams and write the equations. For A and B, you have to write net horizontal force is mass into acceleration. And for C, the net vertical force downwards. And just then you have to solve the equations. Okay, so anybody got the answer yet? So as you can see, for these two blocks, you really don't have to worry about the vertical forces. They will balance each other. You have to just write the horizontal equations. Okay. So we'll just concentrate on that. So for the block A, we have T1 is equal to mass into acceleration. For the block B, we have T2 minus T1 is equal to mass into acceleration. And for the block C, we have the weight minus tension T2 is equal to mass into acceleration. Now you can see you want to eliminate the unknown quantities T1 and T2 to find out A. So if you add the first two equations, you'll get rid of T1 and you'll have T2 and add that to the third equation. So you'll get rid of T2 also. So just add the three equations. So T1, T1, T2, T2 cancels out and you are left with just the weight of the block C on the left hand side. Right hand side becomes sum of the masses. Okay. So these type of simultaneous equations are pretty simple to solve. So you can see that this is becoming this kind of a term here. In this particular case will become 2 upon 8. So 1/4 of G. So G by 4 or 2.5 meters per second square. That is the acceleration. Okay. And now substitute this back in equation 1. So T1 will become 3G by 4 or 7.5 newtons. Okay. And from equation 2, you can see T2 will become T1 plus 3G by 4. So it will become 3G by 2 or 15 newtons. So these will be the tensions. All right, so this should be fairly simple. Okay. Now let's put aside some time for discussing the doubts if you have from the assignment I had sent you. Harsh, in this case, acceleration is downwards, so obvious है ना बेटा, because इसका weight, the weight of the block C is pulling the system down, na? And we are not applying any force on the left hand side on the block A. So there is no option, but it has to go downwards. No? So the free body diagrams is showing you, na? Okay, now do you have any questions you want to discuss from the assignment I had given last time? Question 12, 13, 15. Okay, Bhargav, we'll come to those. '11 also, okay. Just give me a moment, people. Okay, so let's start with question 11. So velocity of a body of mass m is given by this particular relation. What will be the momentum at the instant when the net force on it is 0? Okay. So we'll use the definition here. Okay, so question 11, it says that the velocity of the block is given by this relation. V is equal to V naught T into 12 minus T square. The velocity is meter per second and T is time in seconds. Okay, and the object is at origin at t equal to 0. So let's say its x coordinate is 0 like this. Okay, now from this we can see that if we just expand this a little, it is 12 v naught t minus v naught t cube. This is the velocity. So from this we can get acceleration by differentiating. So we have to differentiate this term now. Okay. So the acceleration is becoming 12 v naught minus 3 v naught t square. Or we can say that the acceleration is this much. Like this. Okay. Now we want to do what? We want to find the momentum, that is mass into velocity, at an instant when the net force on the body is 0. Right? That is what the question is saying. When the force on it is 0, so that means net force only. So at the instant when net force is 0, it means that acceleration of the body should be 0. Okay. So that means this should be 0. So this will give us in general t equal to plus minus 2 seconds, but here we'll take only t equal to plus 2 seconds, because t minus 2 seconds does not make sense. We don't take time as a negative value, so we'll cross that out. Only take t as plus 2 seconds. So now we have to find the momentum. Okay, at what time? At t equal to 2 seconds. Okay, so that is m v naught into 2 seconds into 12 minus 2 square. And this equation here. So 16 mv naught. That becomes the momentum at the instant when the force is 0. Okay. So this is clear. Next we'll move on to question 12. Deep, is the question clear, beta? Okay, good. Okay. So next up, let's come to question 12. So it is somewhat similar, question 12. Similar type of concept we have to use. Okay. So it says the bodies of mass m, it is moving along the x-axis such that the x coordinate as a function of time is given by this relation alpha t to the power 4 minus beta t cube, where alpha and beta are given as constants. X is in meters and t is in seconds. Okay. So again, we have to find the what is the velocity when the force on it is 0. Okay, what is the velocity when force is 0? So you can see that from here, the velocity will be defined as rate of change of position. So differentiate this whole term. Okay. So that will become alpha into differentiation of t to the power 4 minus beta into differentiation of t cube. So we can take t square common here, 4 alpha t minus beta. So this is the instantaneous velocity. Okay. And acceleration we'll get by differentiating this. So further differentiate this once. Okay. So same thing, 4 alpha into differentiation of t cube minus 3 beta into differentiation of t square. So the acceleration will come out to be 12 alpha t square minus 6 beta t, or we can take the acceleration as it takes 6t common. So we have 2 alpha t minus beta. Yes, alpha beta given as constants. Okay. So this becomes velocity as a function of time, and this becomes acceleration as a function of time. So again, we have to find the velocity when acceleration is 0. Okay, or momentum. So we have to find the momentum at an instant t not equal to 0 when force on it is 0. Okay. So from this, F is equal to ma. So force is equal to 0 means okay. So t equal to 0 we won't take because the question has already asked us not to take t equal to 0. Beta upon 2 alpha. This is the value. And now to find the momentum, substitute that value of time. Four alpha t. So t is beta by 2 alpha minus beta. Okay. So this becomes the momentum at the instant when force is 0 or acceleration is 0. Okay, so basically the common approach for both these questions, in you're using these definitions from kinematics, that velocity is rate of change of displacement or rate of change of position, whatever, in 1D motion, and acceleration is rate of change of velocity. Okay, very good. Now let's move on to 13th question. Okay, 13th question, you have to use basically the relationship between acceleration and displacement from kinematics. Okay. So in the 13th question, you assume that this is the muzzle of the gun. This is like part of the rest of the gun and all that. Whatever. Okay. So the bullet starts from inside here with an acceleration but u equal to 0. And by the time it comes out from this side, it has got a velocity v. So we can say that v square is equal to this, okay, where a is the average acceleration. Okay, so the average acceleration will come out to be v square by 2l, which in this case is 500 meters per second whole square. divided by 2 into the length of the gun barrel is 0.5 meters or 50 centimeters. So this will be 4. Yeah. So this will be 2.5 into 10 raised power 5 meters per second square. This is the average acceleration. Okay. So the average force will be mass into acceleration. So mass of the bullet is given to us as 0.05 kg or 500 grams. Okay. So you can write that as so this should become the average force. So basically you are using kinematics. You're taking the initial velocity as 0, the displacement as L. You're finding out the acceleration because the final velocity is given to you as 500 meters per second. Yes, muzzle is the cylindrical part or like the pipe of the gun. That's called the muzzle. Okay, then let's come to 15th question. Okay, we'll discuss. So to find the x and y coordinate, we'll first need to find out the acceleration. Okay, so what is happening in question 15 is that two horizontal forces act on a 4 kg block that can slide on a smooth horizontal surface. Okay, so your horizontal plane is the xy plane. Okay, so you imagine your xy plane, this sort of a surface, like a tabletop. This is your smooth horizontal surface. Okay, and the xy plane is lying in that smooth horizontal surface only. So we have defined our x and y axis like this, let's say. So the xy plane is the smooth horizontal surface. So obviously the vertical plane is nothing but the z axis. Oh, sorry, the vertical axis is nothing but the z axis. This is the vertical. So now on this smooth horizontal surface, you have a block line on which a combination of two forces is acting. Whatever they are, let's say they are okay, lying in the xy plane. So I may not have drawn the forces correctly, it doesn't matter. Okay, because one is having a negative x component, that's just figurative. So the first force, but they are horizontal. Okay, so it's -3 I cap plus 4j cap in newtons, and the second force is 7i cap plus 4j cap, again in newtons. Okay. Now, also for the C part, the information given to us is that originally, that is at t equal to 0, when the motion starts, the block is at the origin. That means it's at 0, 0 and starts from rest. Okay, so that means its initial velocity has to be taken as 0. So we have to find the position of the block, that is the coordinates at t equal to 5 seconds. Find the x and y coordinates of the block. Okay, so let's say it started from here at t equal to 0 and went like something over here at 5 seconds. So how we'll find it? We have to basically start by finding the acceleration. So from this information, we will first say that the net force acting on the block is the vector sum of F1 plus F2, and that is equal to mass into acceleration. So we'll get the acceleration. Okay, so you can see that this net force, it is minus 3 plus 7 I cap plus 4 plus 4. So it is 4 I cap plus 8 j cap in newtons. So that is the net force. Okay. So the acceleration of the block should just become net force divided by mass. Okay, and the mass of the block is given to us as 4 kg. Okay. So when you divide this by 4, you will get I cap plus 2j cap in meters per second square. Now what you can do is you can write this as components. Okay, the x component of acceleration is 1 meter per second square, and the y component of acceleration is 2 meters per second square. Okay, the initial velocity was 0. So initial velocity is x component is 0, initial velocity is y component is 0. So along the x-axis, the motion will be like this. Use the 1D motion equations. So Vx will be equal to Ux plus Axt, and x component of displacement will be in general, it will be Uxt plus half Axt square. But here, it will just become T, and x component of displacement will become T square by 2. And similarly, Vy as a function of time will be Uy plus Ay into T, and y component of displacement will be like this. So in this particular case, this will be 2t, and y component of displacement will be t square. Okay, so this is telling you x and y as a function of time. So you can see from here, at t equal to 5 seconds, the x coordinate will be 25 by 2 or 12.5 meters, and the y coordinate will be 25 meters. So these are the coordinates. So basically, you have to first add the forces to get the net force. Okay. Then from the net force, you have to find out the acceleration. Okay, which we did here. And from that, you have to find out the xy coordinates using the fact that initial velocity is 0. So you can just use the simple kinematics equations separately along x-axis and y-axis, like you do for projectile motion. So any two-dimensional motion, you have to separately find the x and y components by using individual equations along the x-axis and y-axis respectively. Okay, so Bhargav, hope the C part is clear to you. Okay. Yes, always two-dimensional kinematics. Now you need to solve in. See, the Newton's laws part was over when we found out acceleration. Now rest क्या है? Acceleration से मैं velocity निकाल रहा हूँ या displacement निकाल रहा हूँ. So that is kinematics. So whenever you have motion in 2D or 3D in kinematics, you have to write individual component wise and find out the coordinates. Okay, people. So this brings us to a conclusion of this lecture. Now, before the next lecture, I'd like you to work out some questions from H.C. Verma's exercise for Newton's laws of motion. So I'll be sending you a list of questions as an assignment along with the notes of today's lecture. So please make sure you attempt those questions before the next lecture, because that will be crucial for your progress. So that's it for today's session, people. Wish you all the best. Yes, pulleys will come for the first test. Okay. So what we've discussed in today's lecture is relevant from your test point of view. Yeah, probably something will be arranged. Let the timetable come. Okay.